Hello friends, in this video we will learn about how to calculate work done in case of a constant force. So if a constant force is acting on a body, how do you calculate the total amount of work? Basically there are two ways by which you can calculate the work done. The first one in which you simply apply the formula, and then in the second case you use vector dot product. So let us illustrate using an example. So in this example, we have a car, and this car is pushed by a person. His name is Steve. So Steve is exerting a force on this car, and this car is moving in this direction, that is in the straight line. And the force he is applying, the Steve is applying a force in this direction. So basically the displacement vector and the force vector are not in the same direction. There is an angle, and this angle is given in the problem. So this angle is 30 degree. So let's call this angle as phi, and phi in this case is 30 degree. And the magnitude of force is also given. So it says force of magnitude 210 Newton on a stalled car. So this force is applied. So magnitude of force is given, that is nothing but magnitude of F is equals to 210 kilonewton. So generally when we write magnitude of force, we put something like this. So there is a one vertical var this side, another vertical var this side, and this becomes magnitude of force. So if you have any vector quantity, if you want to represent magnitude of that vector quantity, you have to basically put two straight vars, one left side, another right side. The car also has a flat tire, so as to make the car track straight, a Steve must push at angle of 30 degree. So if a Steve wants to push this car in this line, he has to apply a force in this direction, and that is angle of 30 degree. Now the question is, how much work does a Steve do? So that is, we have to calculate the work done by the Steve. So how will you calculate this force? If you remember, work done is given by force dot displacement. So work is equals to force dot displacement. So F is the force vector and S is the displacement vector, and this is the dot product. So F is a vector quantity and displacement is also a vector quantity, but if you take the dot product of these two, work done is basically a scalar quantity. So work done is a scalar quantity. So we can use this formula to calculate work done in this case. If you remember, we can also write this F dot S using vector formula. In vector you might have studied this, that is, I can write F dot S is simply magnitude of F multiplied by magnitude of S multiplied by the angle between them, that is cos phi, that is cosine of angle between them. So I can directly use this formula, that is magnitude of F, magnitude of displacement, and cos phi. Now everything is given. Magnitude of F is given, that is 210 Newton, and the displacement is also given in this problem. So this says displacement is 18 meter. So the displacement is also given. So magnitude of displacement is 18 meter. So now I can plug this value here, 18 meter, and the angle is 30 degrees, so we have to write cos of 30 degree. So we can further write 210 Newton, and this is 18 meter, and cos 30 is nothing but root 3 by 2. So if you calculate all this, this will turns out to be 3.3 into 10 to the power 3 joule, or 3.3 kilojoule. So this is the amount of work that Steve is doing. So we can represent all this using this diagram. So this is the initial situation, that is initially the car is here and then this has moved by a distance of 18 meters. So this distance is 18 meter. Now if you see, this force can basically decomposed into two components. One component in this direction, that is F cos phi. Another component that is in this direction, that is F sin phi. So you see, force has two components. One component that is perpendicular to the direction of displacement, that is F sin phi, that is perpendicular force. Another force that is parallel to the direction of displacement, that is F cos phi. So you see, the work done is only done by F cos phi. That's why we are writing F into S into cos phi. That is work done by this, in this case is Fs into cos phi. So if you see, we have written Fs cos phi. You can also write the same thing, F cos phi times S. That is this is the perpendicular force. That is the perpendicular force multiplied by the displacement. That is the work done in this case. So this is one way by which you can calculate the work done. You have to simply apply the formula, that is magnitude of force, magnitude of displacement times cos of phi. Or you can use perpendicular direction force will not be there, only parallel direction will force be there and multiplied by the displacement. There is another way also to calculate the work done, that is using the vectorial approach. Let us say the same problem, but this time force is given something like this. That is, I have divided the force into Cartesian coordinate I and j. So the force has two components. One component is in the I direction, another component is in the j direction. The I component is 160 Newton in this case, and the bicomponent force, that is minus 40 Newton. So that is in this direction. If the y is positive in this direction, downward direction will be negative. So force has two components. One component is the downward direction, another component is in the vertical direction. In this case, this force has to be something like this, because one component that is positive, another component that is negative. So now I know force in a vector form. I also know the displacement in a vector form. So displacement has two components, I component and j component. So now I again calculate the work done. The formula will be same in this case. The work done is equals to force dot displacement. Now in this case, we will simply use dot product. So let us write, so we are not going to write F into S into cos phi. What we will do is, we will put force, vector form of force and vector form of displacement, and we will take the dot product. Now force is how much? So this quantity is force, that is 160 Newton I minus 40 Newton into J. So this is my force, and then I have to take the dot product. Displacement, I know this term is displacement, that is 14 meter into I. So this is I cap. So let's put I cap, that is a unit vector in the x direction. J cap, unit vector in the y direction, plus 11m, and this is j cap. So basically sometimes they write only j, or you can also write j cap. Both means the same thing, that is unit direction, unit vector in the y direction if I am writing j cap. Now I have to take the dot product. So I have one quantity here, another quantity here, and then I have to take the dot product. Now at this point you should be knowing some result that is coming from the mathematics, and from the mathematics this result you should know, that is I dot I is equals to 1, or j dot j is equals to 1, or I dot j is equals to 0, or j dot I is equals to 0. So this result basically you can prove, and I am assuming that you know this result. So if I use this result, I can calculate work done. So first term I have to multiply this term with this term. So we will have 160 into 14, and this is Newton meter. And then if I multiply this term with this term, this is going to be 0 because I multiplied by j, that is I dot j. So the second term is 0. Now if I multiply this 14 Newton with 14 m, this is again going to be 0 because this is j dot I. So this is again 0. Now the final term, I have to multiply this with this, that is j dot j is 1. So I have to write simply minus, this is a minus sign here. So minus 40 times 11, and this will be Newton meter. So what I have done in this step, I have simply taken the dot product in terms of vector, and you have to remember the fact that if you are taking the dot product of two unit vector that is perpendicular, the dot product is 0, and if unit vector is in the same direction, then it will be 1. So if you calculate this, you will get 1.8 into 10 to the power 3 joule, or 1.8 kilojoule. So this is the total work done in the second case. So now we have learned how you can calculate the work done by two different methods. In one method, you have to take the simply dot product and you have to use the formula Fs cos phi. You can also use the same formula. You can take the parallel force and multiply by the displacement. That is the same formula. You can write either you can write Fs cos phi, or you can write F cos phi times S. In another method, you have to write the force and displacement in a vector form, and then you have to take the dot product, and when you are taking the dot product, you have to follow the rules of mathematics. So with this, I hope you have enjoyed this video. We'll come to the next video. We will discuss more about how you can apply work energy theorem and other stuffs. Thank you.